Hello friends, welcome to G-Centric. So in this lecture we will see what do we mean by mean value or average value. So you can call both in both the names. So we have already studied in our class, in the lower classes, what do we mean by average. So if in terms of network theory, if we have to understand, then let us consider this circuit. We will take a circuit which is given a DC supply, okay. This is a DC supply connected to this circuit. Now this, according to the definition of the average in the network theory, the DC value will be, when we apply the DC value for that period of time, that is, let us consider time period T, we will calculate number of charges transferred. Okay, so basically what we are doing, we are calculating the number of charges transferred in this time period when DC is applied. Similarly, if we change this source to the AC voltage source, okay, so we will take one more circuit. We will take one more circuit, and for this circuit we will give AC supply, okay. So we will apply AC. Similarly, how much ever we have the charge is given, how much ever the supply of the DC is given, same amount of AC also should be given to get the same number of charges transferred in this particular time period. So even for AC, we must have for the same time period same number of charges transferred, okay. So now, but DC and AC values, they will be not be same, okay. So for that what we have to do, we need to adjust the value of the AC, okay. So this value must be adjust, so that what we have to do, we have to adjust this AC value so that we get the same number of charges in AC as well as DC for that particular time period. So basically the definition of average is that adjusting the AC value to get the same number of charges transferred when DC is applied for that particular time period. Okay, so this is the basic definition in the network theory. So in our lower classes, what we have learnt for the formula, so we have learnt that if something in a class, if you have to calculate the average weight of the class, say one person has got, take class 10th, okay, one person has got 40 kgs, say 45, then one more has got 60, then the other has got 55, okay, and someone has got 35 kgs, okay, they all are in kgs. Okay, some 5 students are there in a class, and we have to take their average, okay, the average weight of the class of this 5 people. Now what will be the formula? What formula we have learnt in the lower classes? That is, average will be equal to total of these kgs, 40 plus 45 plus 60 plus 55 plus 35 upon how much we will take? The number of observations. So how many are there? 1, 2, 3, 4 and 5. So there are 5 students. This is the number of observations. So what we are doing basically, to just summarize or generalize this one, we are taking the summation of all this, that is sum of observations over total number of observations. So this is total number of observations that we have made, okay. This is the formula that we have learned, okay. So this, instead of in a statement problem, we can write it in the mathematical symbol. So sum is nothing but we can represent as summation, okay, summation of some function. This is the function of weight. So in network theory we will take it as f of t, okay, then divided by for that particular time period, okay. So this is number of observation is nothing but we will take it as time period. Now still this can be again generalized. How? We can, this summation is nothing but the area, that is, if we can take it as area under the curve. Okay, so this 1 by t will be as it is. Integration is nothing but the area under that curve. So this time period we will take it from 0 to t. We have to put the limit to calculate that much area only. Okay, so it is nothing but the summation of all the areas. So integration is nothing but small, we will take, if this is the curve something like this, we will take small portion of it and we will calculate its sum. Similarly, we will divide everything into strips so that each and every area under this curve gets summed up and integrated. So integrated means in the word itself we have the meaning summing. Okay, summing up. So this is nothing but function as it is f of t into dt. Okay, so this is the average represented as AVG. Okay, so this is the formula for calculating the average thing. Now we will see some of the waveforms, so that we will which comes in AC analysis, we'll take those waveforms and we will calculate the waveforms of that. Okay. Okay, so this is the waveform. So what type of waveform it is? It's a half wave rectifier waveform. Okay, so what does it do? For a signal of sinusoidal signal, it will only take the alternate positive values. It will be 0 for the negative values. Okay, so this is the waveform of the half wave rectifier. So now they have given us the signal of the half wave rectifier, that is in the form of the voltage. Vm is the peak maximum value of the voltage, and here the time period, what will be the time period of this one? Up to here it is a time period after which the again signal repeats. So this is the length of the time period up to 0 to 2 pi. Now up to 0 to 2 pi there is a change in the quantity. Okay, so here is one waveform, then from pi to 2 pi there is another waveform. Okay, so what we will do, up to v of 0 to pi the voltage is conducting. Okay, so what will be its limit? 0 to omega t equal to pi, but it is 0 between pi to 2 pi. So voltage is 0 between pi to 2 pi. Okay, so this is the omega t, that is the arguments we have seen in the last lecture. Now for this waveform we have to calculate the average value. So we have seen in the previous one that what is the formula for the average value? It is nothing but 1 upon time period, the total time period, upon where we have to calculate the area under this time period t curve. Okay, so it is nothing but v of t into t omega t. So now what is the time period? It is 0 to 2 pi. So we will substitute 1 upon 2 pi. So here also in integration it will be 2 pi. What is v of t? Vm sin omega t. Vm sin omega t into d omega t. Now this 0 to 2 pi can be split into 0 to pi and pi to 2 pi. Okay, so I will take 1 upon 2 pi. Vm is common, I will take Vm outside. This is pi. Okay, so this is 0 to pi sin omega t into d omega t plus pi up to 2 pi, then sin omega t into d omega t. Now from the limits pi to 2 pi, what is the value of Vt? It is 0. So this whole term will be equal to 0. So now only we are left with the first term. The integration of sin omega t is minus cos omega t. So Vm upon 2 pi minus cos omega t, limits will be from 0 to pi. So now this minus sign can be removed. So how it can be removed? We will interchange the limits. So what we will get? Vm upon 2 pi cos omega t 0 to pi. Okay, when we change the limit, the sign inside this will be changing. Okay. Now we have got this much, we will substitute the upper limit and the lower limit. So what is the upper limit? We will keep Vm by 2 pi as it is. It is cos 0 minus cos pi. Okay. So cos 0 is 1, cos pi is minus 1, 1 plus 1 will be 2. So Vm upon 2 pi into 2 is nothing but V average is Vm upon pi. Okay. So the V average for this particular waveform, that is the half wave rectified waveform, the average is Vm upon pi. So now if we take the full wave rectifier, here also it will be conducting, this part is also conducting. So now what will change? Only the time period will change. It will not be from 0 to 2 pi, it will be from 0 to pi. Okay. So then what we will take? This is the value of the V of t. Then integrated V average will be equal to 1 upon t from 0 to t Vm sin omega t into d omega t. So this time period will be pi, here also it will be pi. Okay. So Vm, take Vm outside, then the integration of sin omega t is cos omega t. Okay. So the limits will be from 0 to pi. This is minus cos omega t. So if we have to change the negative sign, we will change the limit. So this will be 0 to pi. So what we will get? 2 times of Vm upon pi. So this is the V average for full wave rectifier. Okay. So why are we getting 2 here? Only because the time period is changed. Here half wave it was from 0 to 2 pi, and for this full wave we have from 0 to pi. So this is half wave and full wave. Now if they ask you the signal of the average value of the full wave sinusoidal waveform. Okay. So what you will tell? Many of you say that it will be 0. But there is an exceptional case for the full wave waveform of the sinusoidal. So what is the full wave? We will take this one. Okay, so the full wave is, this is the sinusoidal full wave. Okay, this is 0, here is pi, 2 pi. So the time period will be up to 2 pi. Okay, but what you will say, plus, minus, plus. So because it is plus and minus alternatively, the average value of this waveform will be 0. But we have an exceptional case only for the sinusoidal wave, its waveform will not, so its average value will not be equal to 0. That is because if you see the form factor, which will be taught in the next upcoming lectures, it is nothing but RMS upon average value. So this form factor will be 1.11 and here RMS upon average. So this value is calculated for sinusoidal value wave, that is why we have got here average. So if there was no average, then if it was 0, it would go to the infinity, form factor would be infinite. Okay, so it cannot be true. So what we have is the exception for the sinusoidal waveform. Okay, there exists this waveform will be having some finite value. Okay, because RMS also has finite value, average value also has finite value, that is why form factor is finite, and that is the reason sinusoidal wave average exists. Okay, so now what will be the average of this one? It is nothing but same thing will be taken, that is this minus will be considered here as positive. So this is the case of full wave rectifier. So whatever the full wave rectifier average is there, it will be for the full wave sinusoidal waveform, 2 Vm upon pi. Okay, so both have the same value. Okay, so this is the average value for all the 3 waveforms. Now we will take up the numericals based on this. Okay, we will come to this first waveform, that is we have got a triangular waveform having the maximum value of Im and a time axis t. Now in this case, what will be the time period? If it's here is the origin, see after this time period up to 0 to t, the again same waveform is repeating. So from here to here the time period will be t. Okay, so what is the formula to calculate average value? It is nothing but upon 1 by time period, and area under that time period is this much, which is the, okay, so this is the straight line slope. It is nothing but y is equal to mx plus c. So here c value is 0 because it is a straight line passing through origin. So the intercept will be 0. So what is y axis? Im. So what is slope? It is nothing but y by x. Okay. So y by x is Im upon t into capital T. Okay. So this is y. Okay. So what we will write here? It is nothing but this is I of t. It is nothing I of t into dt. Okay. So here 1 by t. Then we will substitute the time period is also same. So here it is t and here also it is t. It is nothing but Im upon t into t of dt. Okay. Now take the integration. Im is the constant value. Im upon t square. So this t into t is t square. Differentiation of, sorry, integration of t is t square by 2 from limits 0 to t. So substitute the limits here. You will get Im t square 0 and here it is t square. It is Im by 2. Okay. So every time we will not use this formula. So this integration itself means that it is the area under the curve. So what we will take the generalized formula. If it is a triangular waveform, we definitely know that it is the formula of the triangle, that is half into base into height. So to calculate such waveforms, we will take area under the curve upon, so this is nothing but integration. So for the average, we will divide it by total time period. So upon time period. Now what is the area under the curve? That is triangle waveform. So we have half into base is t and height is Im and the total time period is t. So this t and this t gets cancelled. We have again Im by 2. So this is same as the previous result. Okay. So now coming to the second one, we have got a trapezoid. Okay, if we know the formula of directly area of the trapezoid, we can directly calculate it. Otherwise, we have got two triangles of same value, and this is the third area. This is first, this is second, and this is the third one. So it is nothing but I average will be twice into half into. So this is the base of both is same. 0 minus t by 4 is, sorry, this is t by 4 from 0 to t by 4. Here also 3t by 4 minus t is again we will get t by 4. Okay, plus this is 3t by 4 minus t by 4, you will get 2t by 4 into height is Im. So here we have missed the height, half into t by 4 into Im. Okay, so this 2 gets cancelled. T into Im by 4 plus 2t by 4 into Im. Okay, so we have got 3. This is total upon time period t. Okay, we should not forget to write this one upon total time period t. Okay, from here to here. Okay, so this is 3tim. Here also t will come. Okay, upon 4t tim. This t gets cancelled. So this is 3 by 4 times of Im. This is the average value for this waveform. Coming to the third one, we have got from up to here the cycle is same, after that it will repeat. So the total time period will be up to 6. So this is one area and this is second area. If we add this one upon 6, then we will get the V average. Okay, so this is nothing but 3 into 2, that is rectangle. This is also 6 minus 3 is 3 into 3. Okay, so this height is 4. Sorry, this height is 4. So this is 3 into 4. Again, this is also rectangle upon 6. 6 plus 12 upon 6, that is 3 volts. Okay, so this is how we will calculate the average values of the waveforms. So sinusoidal full waveform does not have, it has the finite value of the average. Okay, so its waveform and the full wave rectifier waveform average is same. Half wave rectifier has the different value of average. Okay, so this completes the average value. So in the next lecture we will move on to the how to calculate the RMS value of the waveforms. Okay, thank you.